So now we're moving on to our next session. This will close out this segment of the program, and we're going to be talking about the best practices for building energy efficient media web applications. So we've been talking a lot about various aspects, but this is the first time we're talking about specifically web applications and how that can be done in a much more efficient fashion. So Cassidy Phillips, who I know for several years and is passionate about sustainability, is with swXtch, and he's going to lead this session. So Cassidy, on to you and the panel.
Thank you, Barbara. And I work for swXtch.io. We do, basically we're a virtualized network switch in the cloud. So we enable multicast behavior, things like that. And so I've been in contact with a lot of these concepts that we're talking about throughout the sessions, and it's all very interesting to me. And I have a general passion for efficiency and sustainability, as Barbara mentioned. So I'm excited to talk to Arnaud and y'all. So Arnaud, go ahead and give us an introduction to yourself and tell us about what Radiant Media Player is doing for sustainability.
Yeah, so hi everyone, my name is Arnaud. I'm the CEO and founder of Radiant Media Player. We started looking into sustainability about 2 years ago. Our first steps was to join the Greening of Streaming industry forum in order to start talking with peers and understand, what other people were doing on the matter of sustainability in the streaming media chain. Then we started to look more specifically on the client-side issues. We developed a player that is solely developed with web technologies and can be ported on a wide array of devices, from desktop website to mobile application, smart TV apps. And we wanted to know how we can already implement best practices. What can we do to reduce the energy consumption of devices? Is it possible today to have, something doable for developers who are making web media application around the world? So that's what we've been angling about for the last 2 years.
So what kind of research were you able to do, and tell us about, maybe some of the things you learned in that research that led to where you are now?
Yeah, sure. So our first research was about an API called the Media Capabilities API. It's a JavaScript API that is widely available on most, if not all, modern web browsers and web environments. Basically, this API let us contact the underlying hardware components of the device to tell us if, given a specific set of codecs that are available in HLS or MPEG-manifest, and given a specific configuration of video, can we play that content smoothly and in an energy efficient manner? So that's really the breakthrough with that API. It gives us information about the energy behavior of the device. Is it energy efficient, yes or no? And this API is really powerful because it lets us input settings like frame rates, resolution, bit rates, and we can query dynamically the device, and the device will tell us directly if it is smart in an energy manner to be using that specific configuration of codecs. So that's the first steps that we took. Then we went trying to understand more broadly what is it that we as developers, web developers, can do to build better media application. And we have been engaging with customers and also developers on the subject, and we have already been able to extract a few good practices that can be used in that specific concept of building web media application. The first one is to not use autoplay. So that's something that's not everyone may be happy to hear, but the bottom line is, unless you have a business requirement to use autoplay of media content, then do not use it. Leave it to the user to decide whether they should start content, yes or no. So that's something I think important. And again, some players, some publishers on the market, like people like broadcasters or people that are running website or application where media content is the most important and sometimes even the only form of content available, then there are still cases where autoplay could be used. But the bottom line is, if you can refrain from using it, then do not use it. Autoplaying a video on a web page, on a web app, automatically trigger a vast consumption of energy from networks downloading content from the server, from CPU, GPU displaying content. So this is really an important step that we've been highlighting. Similarly, do not use media content preloading. With HTML5 video, you can preload content from the server before content is even made available to the viewer, to the page. So even if you have autoplay turned off, you can still preload content from the server, and this is something that needs to be avoided, especially for mobile users who are on 4G, 5G networks and may not have a lot of bandwidth to share. So here again, we can see that there is an overlay between being efficient in terms of energy and efficient in terms of cost. One other thing is the adaptive bitrate streaming strategy. So this is more aimed at video engineers that are building media player. When you have an adaptive bitrate technology like HLS or MPEG-, you can play with a lot of settings to make that algorithm more aggressive or more conservative, depending on your use case. The first item you can review is something called device pixel ratio. Latest mobile devices like iPad or high-end Samsung tablets have device pixel ratio of 3 or more. So basically, this means that if you're not careful with your ABR logic, you could throw HD or even UHD rendition to a window player on a tablet, which is complete nonsense given the amount of bandwidth and resource that you would need to decode that content. So do not account for that specific information called device pixel ratio. Keep the resolution of your player, of your ABR logic to your current size of the player. Again, there is no point in throwing UHD or HD content to window player. Sometimes some people really want to have crispy details all the time, all the way, but that's the part where we need to inform the viewer. We need to educate our audience about what do they think, how do they feel about consuming less energy at the cost of losing some of that crispy details, and where can we save bytes without significantly and negatively impacting the viewer experience. Last thing, of course, make your ABR logic less aggressive. You have the opportunity, if you have during the cycle of viewing the content, bandwidth will change, especially for long form content. So at some point in time, maybe you have children at home and they are playing video games and you have a sudden drop of bandwidth. It's very important to understand and to be able to detect those change in bandwidth rapidly so that you can adapt your adaptive bitrate algorithm accordingly. And when you want to go up, you would want to be more conservative, like I'm going to wait a little bit before I switch up to a higher resolution. This will allow us to save a couple of bytes, but as I mentioned here, we are really looking about building applications that really are energy oriented, where the user has a choice, an opt-in choice to consume less, like an energy saving mode that is not built at the hardware level, but at the application level. And provided the user is happy with those settings, we will enable more aggressive energy efficient measures. So yes, you're going up, be more conservative, and you are going down, you have less bandwidth, be more liberal, switch down more rapidly so that you can use less bandwidth, knowing that what you're going to avoid is likely to be deteriorated network environment.
Yeah, it's interesting how all of those things can go hand in hand. That's why I like to talk about efficiency, how you can get the cost, the electrical efficiency, as well as even the amount of clicks or operational workflows down. So that's really good stuff. So tell us a little bit, I know that we want to get to EAL, so what have you guys done together before I go directly into EAL's component here?
So what I've been talking about is, best practices, but in a traditional way. What we want to do next is look at innovation and new or old technologies that can be recycled to dramatically reduce the way media, to reinvent how media content is being consumed on the device. One example would be peer-to-peer assisted streaming, when you can offload some of the server loads of the content being streamed from the server to the client through a peer-to-peer network that would be created by an array of devices watching the same content. And another option, and we've been working with EAL on that specific subject with a common client, Verizon, is using multicasting. EAL has built with our player a very innovative way of delivering content to corporate network using multicasting, significantly saving on cost for media content, not only money cost, but energy cost. And that's really, I think, what the next steps are for us and for many people in that room today, is to think outside of the box and to review new and old technologies and try to use those new and old technology to reinvent the way we deliver media content to our viewers.
Yeah. So with that, y'all introduce yourself a little bit and tell us, what you did with Arnaud, but also what you're working on, and we'll get into it a little bit.
Yeah, sure. I am in the streaming media industry back from 1996. In 2002, I wrote a book, the Streaming Media Handbook. And since then, I work with many celebrities and corporations to help them with their streaming media solutions. I also founded a couple of companies. The last one I founded is called Multicast Agent. And what the Multicast Agent does is basically helping bring multicast back to the network. Because remember that during the pandemic, everybody were outside of the network. And when that started and everybody got used to Zoom as the mean to communicate, they adopted certain ways to do business, but that has changed. And now more and more companies are asking people to come back, employees to come back into the environment. And that's where multicast comes to play, because it was a technology. It's not a new technology. It's been there for a very long time, until Microsoft Windows Media shut down. It was the technology to deliver multicast on corporate networks. And the big advantage is that it's using less computers. It's using less electricity. It's basically simplifying the way that you bring video into the end user, and also reduces the need for all these companies to have very wide tie points to the internet to bring a lot of volume of data, unicast data, into the network. So Multicast Agent, because I deployed many of these solutions before, the way it was built was using microservices architecture. And the purpose was, don't invent the wheel, basically make it quickly to deploy and to manage as well. One of these microservices is the Radiant Media Player. And working together with the Radiant Media Player API made it so easy on preparing, for example, a perfect UI experience for the user. You click on one link, and the player tries to get multicast from the Multicast Agent. If it doesn't, it rolls over to unicast. It's done in milliseconds. So it's perfect. You have a player that allows you to do that. The other component is to report. The player has a lot of ways to report user activity. The player knows where the user is coming from, a lot of details about their behavior during the stream, and it can report and post it. So we are able to post it to Splunk, we can post it into Google Analytics and other third-party platforms. It's a really easy, small footprint installer that goes on Windows or Mac. The challenge is to bring it to mobile devices. It needs an app, of course, but that's next. And that's really how we are working together to provide an end-to-end kind of a solution to those corporate networks.
Okay. Now, was there a push for sustainability from the client in this case, or have you been receiving that type of request?
I worked many years setting up servers inside networks, hundreds of servers in large corporations over different countries. Then everybody moved to the cloud, and then everybody started talking about climate change. And I thought, me as an individual, what can I do? And I see governments trying to help, but they are so tied up with their political constraints. I'm a big fan of educating the user and making them aware that there are other ways to do things, and then letting them lead basically the cause. So when I realize, okay, there is an opportunity, everybody's going to go back to the buildings. Why not to come up with this solution and to tell them, start using it. It's really simple to deploy. It's really easy to report. And it's going to allow you suddenly to take all these people you're trying to bring into the buildings and give them video. Because imagine that a remote site has 50 people on a 100 meg downlink stream, and those 50 people are trying to pull a 4 meg per second video. It ties up everything, it clogs everything, and it disturbs mission critical software. Maybe the site needs to have some kind of e-commerce transactions and who knows what. But bringing a multicast stream in means you only bring one 4 megabit per second, and everybody inside the building are sharing it. I want just to bring here, there is a misconception. People think that multicast is broadcasting, meaning like from one to many. It's not. It's technically send one stream into the environment and let the users decode and watch the video inside the environment. So that kind of what's driving me, because I think that the more people will be able to use this technology, they will then be able to go to their managers and say, look what we are doing. We are reducing our carbon footprint inside the company. We don't have hundreds of servers hosted outside on the cloud, and then we don't have hundreds, if not gigabytes of data coming into the network, traveling across the network. Or a lot of companies are saying we're going to bring servers back into the network. Wrong. Don't bring servers into the network, deploy multicast, because what you're going to do is take those servers that generate so much CO2 that they will basically clog the network again and create an environment that is not healthy, not sustainable.
Right, and are you finding that? I mean, I hear you're kind of saying it already, that the sustainability has gone hand in hand with the operational efficiency, right? It's actually easier to use the system at the same time that you're actually more efficient on an electrical or a carbon level.
Yeah, that's correct. When I prepared for this meeting, I did a quick search, found the famous Shift project report that was afterwards adjusted, and I was looking on the numbers, 0.4 kilogram CO2e for 1 hour of unicast streaming. It's huge. Then I saw the numbers that the IEA released about the global cloud computing usage. Global cloud computing counts for over 3% of the greenhouse gas emission compared to 2.4 that commercial flights generate. Imagine, if you compare apples to apples, we are so little compared to other industries that are creating pollution. But even with our industry, the 3% or the 3.5%, and if these numbers are correct, of course, I don't know if they are correct, but let's say that they are real. these numbers are something that we have to work with. And in places like this conference, for example, we have to take the information that we are learning here, go back to our offices, go back to our managers, and tell them, this is the problem. Here, specifically with what we do, we deliver video, and look how much damage we're making when we are delivering video in the wrong way.
Yep. Yeah, so I guess on that note, what kinds of predictions do you have? What are the next steps for you immediately? And, what do you see as the future possibilities that might be interesting to you in this way?
I personally think that we have to push really, really hard and develop technology that will bring multicast to the last mile. I know that there are pilots with 5G, some pilots with fiber. It's really important to allocate resources from the right companies that are expert in the field and to work on that because that's going to reduce tremendously the electricity and server power and pollution that we are creating with unicast. Technologies like the multicast agent can be converted to a small print going into the router in your home. Then you can decode it locally. The Radiant player can be, with the right modifications, the visual representation of that signal. So the same way that we are doing it on computers, and you will be able to do it in the home, it's already inside the browser, right? The Radiant player is in the browser, and it's technically decoding UDP signal into HLS. It's working. There is nothing to prove here. It's working properly. So I think that we have to put some effort in there and try to bring multicast into the last mile. It's going to make a huge difference.
Yeah. Yeah, and I do see a question here. Do we think that it requires a different skill set to deploy these things or operate these things, or is it more of a different mindset? And I can let either one of you answer that. Go ahead, Arnaud, if you want. You talked a lot about configuration.
I can take that one. Basically, web applications are part of our day-to-day lives in many ways that we don't understand, whether we are going online to do some shopping, whether we are doing some bookings, or whether we are just checking times for train arrivals on the mobile devices. So yes, we need to understand exactly where are the pain points, where is the energy being consumed, we're building web application, even outside the context of media application. Media, the moment you have, video content playing in any environment, in a browser or in a mobile application, smart TV application, the consumption is necessarily going to go up, not only because of the network, but because of the decoding energy required to display the content. And then you have the display itself, and you have tools like Apple computers have released tools with Xcode that lets you verify if, when playing HTML5 video full screen in Safari, you are being energy efficient through Quartz debugger, it's called. So you see, having the knowledge of that tool exists with Xcode is where we're gonna have to need people with specific skill sets. Because if you're just a random web developer and you're just putting video on a website, you will not know about that tool. If you are a video engineer, or if you are a specialized web media developer, you will know about that specific API, that specific tools that will let you decide whether or not you should configure your HLS content in a certain way, whether you should, what kind of data, as Ayal was saying, collecting data from the device, what kind of data are available, what do we need to collect, what energy KPI do we need to collect to make the viewer experience acceptable while reducing energy consumption. So yes, I would say that the skills will need to be learned, but for people that are already doing web development, it should be quite learnable. I will make a parallel with accessibility. Web developers, sometimes for us, it's a pain to, dealing with accessibility requirements, because there are a lot of, notions that do not come to our minds, like color contrast. I'm not a UI designer, so I don't care about color contrast, but now I'm going to start caring because somewhere is telling me I should care for accessibility purposes. So yes, it's going to be a new set of skills, but still it's going to remain, I would say, acceptable and learnable.
Yeah, and I think within your answer, you kind of addressed the other question from Dom about, where is the energy saving in multicast? And I think kind of, if I could summarize and paraphrase a little bit, you're basically saying I'm either using something or I'm not. I'm either using certain resources to decode these streams or build these unicast flows, or I'm not. And the way that you guys have put this together, you're actually just reducing how many resources you're tying up to actually create the operation.
Yeah. And it's not for everybody. It's not, Cassidy, multicast is not for everybody, because in some use cases, if all the employees are outside the network, why are you going to go with multicast? But what you can do, if you decide, okay, multicast is not for me, so make sure that you are going to a provider that use renewable energy, sustainable servers. If you need components in your workflow, use components that help reduce CO2e. You don't have to always use multicast. You can use certain components that will reduce in general that emission that we are creating.
It depends on the workflow needs, right? And I think, you talked about this throughout as well, Eyal, the education. Azil made this same proposal that we need to work on how we educate people on these new possibilities and how the workflows they're familiar with could change a little bit to be a little more efficient. I think of it as kind of the reducing clicks, right? So everything's more efficient overall. Well, we have just a minute, and I know, Barbara, you want to be able to tie things up a little and also segue into if there's any overflow questions, where we would go.
We don't have, well, there's a comment about multicasting to be promoted in the cooperation of all actors of the internet ecosystem and to have more evidence that others are asking for. And I think that's the key here, is that this is just the beginning of the conversation in all of these areas. And having this conversation really leads to more research, more communication, more alliance in terms of standards and best practices and things like that. We have a minute left to last words of encouragement and inspiration, if you like, and then we're going to hit a break. Anything?
Give that to
Yes.
All right.
Yes, just one last thing is obviously, as Barbara mentioned, this is just an introduction to doing things more meaningful and measuring with actual actionable data, and is the next step. And I know the Greening of Streaming is starting a group specifically dedicated to that, finding ways to collect what's data from the devices. So that would be the next step. And once we have this energy measurement, we can start playing with all sorts of configurations. And I'm sure we're going to find, things that we think are pretty straightforward to actually not be that straightforward when we have those data. So that would be obviously the next step, is measure the watts from the devices.
Super. Well, we've reached the end of the session. I want to thank Cassidy, Arnaud, and Eyal. I should also, again, thank Arnaud for being a sponsor for this event. So we really appreciate that as well.